In this tutorial, you'll learn how to solve a quadratic equation by completing the square. So we'll talk about this picture to the right in a minute, but why don't we warm up with doing a little bit of factoring. So pause the video and try and factor these two trinomials. Alright, let's take a look. Hopefully you were able to get these two factors, and maybe if you look real closely, there's something interesting about both of these solutions. And even though the number one answer doesn't match the number two answer, there's something about the two factors in each that is repetitive, right? So if I have a quantity times its exact self, then that means I'm squaring that quantity. So these two trinomial factorizations can actually be rewritten like that. Did you see that, right? So I take that one factor and I write it only one time with a little square sign at the end. So this is a main idea for today. This is what we call a perfect square factor. So whenever your two factors are identical to each other, you can simplify them up by using that square sign. And that's what we want to do today. Right? We want to write these perfect square trinomials. So if you're following along in your notes, you could fill this in the table of contents with the appropriate page number. All right, let's begin. So today's learning target is that you can rewrite a quadratic equation as a perfect square factor by adding a totally brand new, made up by you, appropriate constant value. So I'm going to add an addendum here. You're also going to solve the equation. So there are three things you need to know how to do today. First, you need to be able to identify the b value in your quadratic equation. Second, you need to calculate half of the value of b and then square it. And then third, you have to factor your trinomial into perfect square expression, right? You need to factor that new trinomial into a perfect square. All right, so let's take a look. This looks pretty crazy, but we're going to do something called completing the square. So I want to show it to you visually first, and then we'll get into the mathematics, which is going to be very simple for you. So these are called algebra tiles, right? This here is a square that has an unknown length and an unknown width, but because they are the same size, I can call them both x's, and the area of x times x is x squared, so that should make sense to you. This is an x squared piece. And if the length of this side is x, then that means the length of this rectangle will also be x, right? So I want to shorten up these pieces, so I'm going to call these widths 1s. Okay? All right. Now, what we're going to do today is we are going to visually take this entire object and fill in this negative space, this empty space, I should say. Fill in this empty space here, right? We want to fill that in, and that's called completing the square. So the trick is to understand that if this is 1 unit long, then if I extend each of these parts and I extend each of these parts, then I will find out what the value I need to add right here to make my image a perfect square. Does that make sense? So if I have my perfect square image, how many unit pieces did I have to add? That's right. I had to add 4 tiles to complete this square. So we added 4 tiles here to complete this square. Right, so let's take a look at this again. 4 tiles would make this a complete square. So that means that this side and this side would be equal to each other. So the trinomial would be x squared plus 4x plus 4. Now if I wanted to factor this, right, I would be looking for something that has a product of 4, but has a sum of 4, and that would be 2 and 2, and that makes sense, right? Positive 2 and positive 2. Well, that makes sense because I told you today all of your factors need to be repeats. Now here's something interesting. Remember when I talked about how long this was and how long this was? Well, let's look at the length of this square. That's x plus 2. And let's look the total length of this side. If we added that all up, that would be x plus 2 as well. See that? Those are our factors. That's pretty cool. All right, let's take a look at these algebra tiles one more time. So I have a new question here. It says find the value, right? Find the constant value for c that would make this a perfect square trinomial. Well, let's start by using these algebra tiles, right? So I have one of these x squared pieces, and I have 6 of these skinny rectangular x's. So 1, 2, 3, 4, 5, 6. Now, if I put all of these pieces here, does it make sense to you that I'm not really creating a square shape? Right? Does that make sense? So I'm going to take these 3 over here, these 3 that we have, and I'm going to use the horizontal ones. See what I just did? So I still have 6 total x pieces, right? Still have 6 total x pieces. Now the question is, what do I need to put in this constant position? So let's extend these sides, extend those sides, and count them all up. So the answer is 9. I would need to put a 9 in this position here to create this as a factor times itself. Now remember how we found those factors, right? That's an x plus 3, that's an x plus 3, and there's our perfect square trinomial. Perfect square trinomial, perfect square factors. I got another little hint for you here. If you don't want to use your algebra tiles, you can always find that perfect square factor by square rooting the first term, square rooting the last term, and stealing the sign from the middle. That should sound familiar to you. All right, let's try this one more time. So for this one, when we use our algebra tiles, we're going to have 1. Now I know that says r squared, and our tiles say x squared, but it doesn't matter. And then here I have a negative 8r, so I'm going to use these red figures to represent negative. Now remember before when we started making this really long rectangle, but what we wanted was really a perfect square, right? So I'm going to split this term in half every time. I'm going to split this term in half every time. 1, 2, 3, 4. All right, so I don't expect you to draw out algebra tiles every time you want to complete the square, but I'm hoping that these examples really helped you to get an idea of how it visually occurs, right? So there are 16 units here. So C would have to be a 16. Now, in this problem, I'm going to ask you to try without using the algebra tiles. So in my first equation, which was this, and my second equation, which was this, and my third equation, which was this, we had a starting value of 4, a starting b value of 6, a starting b value of -8, and we had an ending c value of 4, an ending c value of 9, and an ending c value of 16. Now, it doesn't seem like it, especially over here. It doesn't seem like these numbers have a relationship to each other, but they do. And this is the relationship. Whatever your starting b number is, if you take half of it and you square it, you'll find the answer for C. So as long as you know how to find the b position number, and as long as you know how to find half of it, and to square it, you can do this problem without needing all those algebra tiles. So again, the formula is find the b value, take half of it, and square it. So there's my b value. Now I want to take half of it and square it. Half of negative 10 is negative 5, and negative 5 times negative 5 is positive 25. So I would need to add a 25 in the C position to make this a perfect square trinomial. All right. So this is an example of how the algebra tiles don't work for every problem, because remember when we were building our skinny rectangles here, we would split them up. We put half to the right and half down below. But what happens with something like this? Right? If I had 1, 2, 3, 4, 5, that wouldn't be a square. That would not be a square. All right? So what we're going to do here is use our fancy formula. We're going to take half of b, we're going to square it, and that'll be our answer. Now here's the deal. When you take half of b, if it's a decimal, do not convert it. Just leave it in fraction form. So we're going to leave this in fraction form. We're not going to convert it to a mixed number. We can reduce it if it's possible, but that one's not possible, so we're going to leave it in fraction form. And then your final answer will be this. So if this was a multiple choice question, and you gave me a 6.25, that would not be a choice. Okay? So I want you to leave your fractions in fraction form. So this one was a bit of a challenge for you, just to see if you're paying attention to this formula and how it works. This is it. This is the hardest part of today, that you need to create a trinomial by inserting a brand new number, and every time it will follow this formula. Okay? All right, now before we start solving problems today, I want to see if you can answer a few of these on your own. So pause the video, give them a try. All right, let's check your answers. How'd you do? Remember, leave it in fraction form. All right. Now, pretty soon, I'm going to start putting some equal signs along with these questions, right? I'm going to put some equal signs, and maybe I'll put a 0 here, maybe I'll put a number here, but we're going to start doing solving, right? And that's totally different than just finding a random number to make a perfect square here. So solving requires a couple more steps. So let's talk about how you solve something that has a power of 2. Okay, so all the work we've been doing so far have been with linear equations and linear functions, and those have powers of 1. So what happens if you have an equation like this and you want to get x all by itself? So you do this. But x is not by itself, right? So we need another inverse operation, and hopefully you remember the inverse of squaring is square rooting. And the property of equality states you have to do it to both sides. Now I know if you pick up your calculator right now and enter the square root of 9, it's going to tell you the answer is 3, but your calculator is technically sort of wrong, okay? So when you take the square root of a value, you actually have 2 answers. You have the positive answer and you have the negative answer. So the answer to this is positive 3 or negative 3. But we're kind of lazy mathematicians, so instead of writing it twice, since we know they're both 3's, we tend to put our positive and negative signs right next to each other like this. And this is how we say it. X is equal to plus or minus 3. Even though it's positive or negative, this is how we read it. X is equal to plus or minus 3. That's the answer. Now you could write it out the long way, or you could write it out the short way. All right, now that we've covered how to get rid of a square, let's take a look at something a little bit longer. So because this is all in parentheses, I am allowed to take the square root of the whole thing. Now remember, a square and a square root are inverses. And since there's nothing to multiply by itself anymore, I technically don't even need those parentheses. Now, do you remember to write what you need to write on the right-hand side here? Do you remember what you need to write? When you take the square root of a value, there are both a positive and a negative answer. All right, now this part is new for you. If I want to isolate x and I subtract 3 from both sides, technically, this is what my sentence will look like. Now I'm going to put my negative 3 first, but it doesn't matter. And technically, this is what I've got. All right, and this can be simplified because it's actually 2 questions, or 2 statements, I should say. It's negative 3 plus 5, and then negative 3 minus 5. So those are the 2 mathematics that we're going to do. That's the 2 mathematical operations. So negative 3 plus 5 and negative 3 minus 5. And that's how we get our 2 solutions. I think you can handle this. Now we're going to put these 2 things together. We're going to put this together with this. Okay, so let's see. In order to be successful today, you're going to have to follow these 5 rules. I know they seem scary, but they're not. Okay, the only thing I haven't talked to you about is this one right here, step number 1. And the good news is, it doesn't happen very often. But if I'm going to challenge you, step number 1 will come up. And that is, before you begin, you should always look for a GCF. And here's your hint. If A is bigger than 1, you probably got a GCF. So you're going to divide everybody by whatever A is, and you're going to factor that out. Or actually, not even factor it out. You're just going to eliminate it. Step 2 is make sure that your trinomial has all of its constants on the right-hand side. If it does have a constant already, we're going to move it over because we're going to create a new constant so that we can factor it into a perfect square. Then we're going to do what we just talked about, and we're going to use half of b squared in order to create a brand new equation. Then we're going to factor it out, and then we're going to solve it. Right? And don't forget about that plus minus sign. All right, let's just get down to it. Let's take a look at an example. Pause the video, look this over. Okay, let's talk about it. Step 1, if A is bigger than 1, divide out that GCF. It's not, so we move on to step 2. Step 2 is move all the constants to the right-hand side, so that's what we did. Step 3, add a brand new constant, right? This is how you add the brand new constant. And then square root both sides. Write your plus or minus sign. Use your property of equality. Get your 2 final solutions. So hopefully you had a long enough time to look this over by pausing the video. And now you're just ready to watch me solve a question. All right, so before it's your turn, I'll give you plenty of questions to try. Just watch and learn, okay? Step 1, look for GCF, none. Step 2, move the constant to the right-hand side. And that's going to make it a positive 12, right? I don't even need to write that. Notice I left a giant space here. I did that on purpose because I'm going to use my formula to introduce a brand new number. Now I want that number to be a perfect square. So I'm going to take half of the b value. Half of the b value is 2. I'm going to square it, which is 4. And I'm going to add it here and here. Because you have to be fair. You can't just alter the problem and change its value. So by adding 4 to both sides, we've technically kept it equal. Now, this math is pretty simple. And this needs to be factored. Here's the shortcut. Set up your perfect square. Take the square root of the first term. Take the square root of the last term. and steal the sign from the middle. That's it. You just completed the square. And now we're ready to solve. Square root both sides. Remove the parentheses. Add your plus or minus sign. Be sure to do your inverse operation. And now you can either write this out or do it in your head. -2 plus 4, -2 minus 4. Alright, pause the video if you need to look it over, but I'm going to show you another one. Alright, here we go. Step 1, look for a GCF. Nope. Step 2, make sure the constants are on the right-hand side. Leave a nice empty space. Step 3, take half of b and square it. Whatever that value is, you add it to both sides. Step 4, factor the left-hand side, square root the first, square root the last, steal the sign from the middle, make it a perfect square. Alright, we have just completed the square, and now we're ready to solve. Square root both sides, remove the parentheses, put your plus or minus sign here. Now, I'm not going to write it out, I'm just going to do the math in my head. -3 plus 2, -3 minus 2. That wasn't so bad. Alright, I think you're starting to get the hang of this. Alright, one last tricky problem and then you're on your own. Step 1. Look for a GCF. I'm actually not going to factor it. I'm going to use a division property of equality here and just rename it, right? It's like changing 5/10 into 1/2. So I'm just going to rename it. By dividing by 4, I get this, and this, and this. Alright, let's complete the square. Take half of b and square it. Don't forget to add it to both sides. Write your left-hand side as a perfect square factor. Square root the first, square root the last, steal the sign from the middle. -4 plus 16 is 12. Alright, I see something going on here, which I didn't anticipate when I made this example. However, that's okay. I'm going to square root the left-hand side, but I'm actually not going to square root the right-hand side, and that's because the square root of 12 is not perfect. It is an irrational number, which means it's a decimal that goes on forever and ever and ever, never repeats, right? So what I'm going to do is, even though I'm not going to take the square root of 12, I'm going to let you know that the answer would have a positive and negative value. But I'm going to leave the square root of 12 right there underneath the radicand. I'm just going to leave it there. Now, technically, this is not accurate, but I haven't taught you how to simplify this, so I know it doesn't make sense. So I'm going to let you leave it like this today. That is okay. I mean, what I mean is, like, the square root of 12 is kind of like 5/10. It can be reduced to another fraction, but you haven't learned how to reduce or simplify radicals yet. So I'm going to let you leave it that way. But don't forget that plus and minus sign. So we're still going to figure out the rest of this math, but the good news is your answer is going to stop right here, because you can't add 4, which is a rational number. You can't add it to an irrational number. All right, so 4 plus the square root of 12, it's kind of like saying 4 plus y. You can't add them together. They're not the same. They're not like terms. So we're going to leave that just like that. It's time for you to try 2 on your own. Use what you learned in the examples I worked out to try these 2 questions. Pause the video now. Okay, let's see how you did. Here are the answers to numbers 5 and 6. So that concludes the introductory lesson on how to solve a quadratic equation by completing the square. Those are basically the types of questions you'll be asked on the end of year final exam. But I think you're ready for a bit of a challenge, so I'm going to show you some more difficult questions in the next few examples. So let's take a look at this question. Step 1, look for a GCF. Step 2, move the constant to the right-hand side. Step 3, rewrite it as a perfect square. And this is where it gets tricky, right? We want to do half of b squared. But remember what I said? If half of b is a decimal, do not convert it. So we're going to leave it as 3/2 and we're going to square it as 3/2. So that means we're going to add 9/4 to both sides. All right, you see that? All right, left-hand side needs to be factored. So here we go. Square root the first, square root the last. Now when you square root a fraction, you just do it 2 different times. Square root the numerator, square root the denominator, and that's how you find your term. And don't forget, steal the sign from the middle. So there's our perfect square. Now over here, I'm going to rename this as -4/4 because that will help me to combine this. -4 and 9 is 5/4. Alright, now we're ready to square root both sides. Now the good news is, not much to do over here. The bad news is, I do not want to take the square root of 5/4. So here's the good news. You technically don't really have to, but remember, square root of a fraction is the square root of both the numerator and the denominator. Now you may not want to square root 5, but you certainly can square root 4. So let's write our plus and minus sign. Let's leave our numerator alone, but let's simplify our denominator. Now the reason I'm doing that is because my fraction on the other side is also 2. And when the denominators match, you can actually do some math. So let's subtract 3/2. And now this is what we get. Now pay close attention. -3/2 plus or minus the square root of 5/2. Now that is crazy looking. I know it's crazy looking. Technically, this is an answer. But I'd like you to go one step further and kind of really understand here that if you have matching denominators, you can add the numerators. Now technically, our numerators are rational and irrational, but we could simplify this to a single denominator with a math sentence in the numerator. Again, this is good, but this is better. I know that was pretty rough, huh? That challenge was pretty crazy. So maybe you want to pause it. Maybe you want to go back and watch it again. But I think you're ready for the challenge. All right, I got 2 more for you here. Number 7 is just a small challenge. And number 8 is the exact one I just did. So try not to rewind here and go back. Try it on your own, okay? Pause the video, give it a go. Good luck. All right, let's see how you did. How did you do with number 7? Did okay? Again, number 8 I worked out for you already, so you can rewind if you want to go back. But really take a good look at number 7 and see if you got it right. All right, that concludes our lesson on completing the square. Give this last question a try and let me know how you do.